Hello, and you are listening to Bill Murphy's RedZone podcast. I interviewed leaders who inspire me in the areas of exponential technologies, business innovation, entrepreneurship, thought leadership, enterprise IT security, neuroscience, philosophy, personal development, and more. Welcome to the show. Welcome back to the show, everybody. This is Bill Murphy, your host of the RedZone podcast. Today, I invited on a security savant. And what I mean by that is this is a person who I've been working with for 17 years and literally is so attuned with computers and technology that literally when he walks in the room, can literally hear the health of the machines as they're spinning quietly in the background. It can tell whether things are wrong or not. So he is definitely very powerful mind, a very deep thinker. He runs the security teams and a lot of the business functions of RedZone Technologies. And I asked him to come in and talk today specifically about some very interesting projects that we're involved in related to passwords. You might imagine as a CIO, as a business leader, why am I refocusing on passwords? Because what we're finding is in my private conversations, I'm getting asked this a lot about passwords and also multi-factor authentication, et cetera, because this has a profound impact with the cloud. It has a profound impact with your on-premise, your off-premise, your mobile users, authorization, authentication, roles-based access control. It really bleeds into some very important context around security. But at a raw fundamental level, James in this conversation talks about how you develop passwords that actually aren't going to be cracked. We just got done with an exercise. Our teams got done with an exercise where we, as a response to a security incident, ran a password cracker on a couple thousand user organization and cracked a huge chunk in about 4 seconds, another huge chunk within about 20 seconds, and the balance within about a day, with only about 100 of these multiple thousands that were uncrackable. And what was the pattern that creates a very strong, powerful password? And the title of this podcast that's in the blog is Make Your Passwords Interesting, Not Difficult. So what does that mean? What does it mean to have an interesting password? So you're going to get a lot of value out of this. It's a 30-minute interview, and you can, as listening to this, forward it onto your teams. I think you'll find that you'll learn quite a bit about passwords, how to lay in two-factor authentication. We're going to talk about wire transfer fraud and how to avoid that, and talk about some architecture issues with passwords as well. So I really am excited about this particular episode. It's super tactical for you, but has a huge ripple effect as you're planning and designing both your offense and defense strategies with cloud, on-prem, and securing your businesses. So with that, with no further ado, I want to welcome you to my conversation with James Crifasi, CTO and VP of RedZone Technologies. Okay, so let's talk about passwords. We have James Crifasi here today, who's the CTO of RedZone. And we had a couple interesting happenings this past week that we thought would be good to share with the audience, and one of them is passwords, the creation of adequate passwords for an environment. So do you think that the old ways of creating passwords are potentially might be done?
So we've been called in for quite a few issues that were classified as hacks where in reality someone lost their password. If we look at...
Lost or got hacked?
Lost their password, or someone guessed their password. No indications of someone actually doing the effort of hacking. For all we know, they wrote it down on a Post-it and lost it. But if we look at that, and then recently we had a security incident where we were allowed to take about 1,500 different accounts and crack them to answer the question of how good are the passwords. So we took these 1,500 accounts, and what we're able to find is that most of what IT trains users on and kind of the IT passwords themselves that were thought to be strong were cracked very, very quickly. And this became important because a lot of the calls that we get about hacks in reality are really just someone logging in as the user using their password. So if we take this as an example, out of 1,500 accounts, we were surprised to figure out that on a really, really low-class, slow machine that was not good at all, about 250 of the 1,500 were cracked instantly. So that means
250?
250. So that's microseconds. So not fast, but instantly. Past that, if we look at passwords that were cracked in within 20 seconds, it was almost about 600 of the 1,500 could be cracked in 20 seconds. And then almost 900 of them could be cracked in 5 hours. So if we look at this in terms of a malware, that means a simple malware running on a relatively low-class end-user PC can crack the majority of passwords in an environment, and no one will even notice that the cracker's running because it doesn't need much CPU or RAM, and no one has to exfiltrate data. What we also found is, like in most environments, the complexity requirements were on, and a lot of the passwords were 11 to 15 digits long.
The complexity requirements are on.
So that's you need to have 3 of the 4 uppercase, lowercase, number, special symbol, your standard pieces there. But they were also 11 to 15 digits. It's a pretty long password. And it was fun from the IT point of view to run the cracker because we found that we had some 5-digit passwords that actually outlasted the majority of the 10 to 15 character passwords. And what we realized is that how the crackers are working is a little bit different than what everyone's been trained and what we've really looked at. And so just as an example, a lot of people have been trained when you create a long word password, you sit there and you say, well, E I can replace with a 3, and A I'll replace with an @ sign, and I'll replace with an exclamation point. And people have learned these mnemonics on the keyboard to figure out, okay, how do I remember all these annoying special characters and still have a password that I don't have to write down all the time? And what we found is anyone doing that, basically with the amount of research going into spell checkers and predictive typing and things like that, all of that's being built into the dictionary for the cracker. So all of those common replacements are actually built into the system. And we had some very, very long, complicated passwords that were found almost instantly because they were a standard replacement of characters. So we had one that, as an example, had $2 signs, 2 @ signs, an exclamation point, 4 numbers, 7 letters, and it was cracked instantly. Because even though it should be really, really long and really, really hard, when they look at it, it's actually a visual message. And as that research keeps getting done, to make predictive typing better, and as people fail to write English anymore in text messages and things like that, those are all databases that cracking systems can use. It's all basically a word dictionary that can be downloaded from Google, from your phone, from wherever, and used as a simple dictionary attack as opposed to a very hard character by character numerical crack.
How big is that dictionary, you think?
So we did some checking. I can download the Webster's Word Dictionary was 2 megs, and then the Hacker Dictionary that we were using was about 550 megs. So 250 times the size of a Webster's Dictionary, and that was just English. And of course, a lot of the crackers, you want to have variants of English and foreign languages. And there's also dictionaries that are being used now where you can get very simple downloads of movie titles, actor names, things like that. So that's interesting because people would think, well, that's not really a word, it's a phrase, but it's loaded in a dictionary. So that means even though it's 20 characters long, it's still just a word from a dictionary point of view.
Or the title of a movie.
Title of the movie, title of the book, all downloadable. You can basically pull a download of the title of every movie since, I think it's like 1912 or something like that, or some age-old number. And it's not very big because it's just a text string. It's not like it's the IMDb database, although I'm given to understand IMDb will also let you download a text file of all the actor names. But it's all stuff available to programmers. It's all stuff available on the internet. And then when you run it through a cracker, it's all stuff that's actually really, really useful. A very common password issue right now is winter. I think everybody loves Game of Thrones. So winter is definitely coming into all of the passwords that everybody has for sure. But really the issues that we found were habitual passwords or people having a password policy, but the password policy is based on something visual, or even worse than that is keyboard patterns. Keyboard patterns have actually been a no-no for about a decade now, but people are still using them. So it's kind of where you start from Z and you go up the keyboard, and then you start at 2 and you come down the keyboard. And people think, well, that's got a lot of funky symbols and stuff in there. In reality, anything on a keyboard that's simple to type, that's also in the dictionary.
What's the visual one that you're referring to? Are you talking about like when you pick a map, like point and click on like here's the
No, so visual being if you take the word message and you replace the A with a @ sign or a E with a 3, visually in your mind it's still the same word. But unfortunately those are patterns that are actually really easy to get into a dictionary. When you have all the developers working on that predictive typing and trying to help people write correctly, all of that can be reversed, downloaded into a very simple sheet of what are the most common things people do. And now all of a sudden you have a nice dictionary you can run as a password cracker. And so visually that's what you're really talking about, is they're trying to type something that makes sense if they imagine it in their mind. And unfortunately the computer can predict that better than the people can. So it becomes pretty hard to make a good password. And actually, in this case, a lot of the IT and other developer passwords were cracked quite fast. And a lot of them were the ones that are supposed to be hard. A lot of them weren't even words. It was just a list of symbols. But people who are going to type lists of symbols will naturally have a keyboard pattern. And you think about all the research keyboard manufacturers do to figure out how expensive a spring do I need for each one of these keys, because if I can save 20 cents by having lesser used keys have a weaker spring, people have done that research. So people know what keys are most used. So from a cracking dictionary point of view, that's not even difficult math. That's using data sets that are available and a little bit of statistics and then build that into the dictionary set. So all those end up being pretty easy. And so then it comes down to, what are people supposed to do for passwords? So when it was related to this incident, the interesting kind of hurdle to tackle was the issue that people were very reluctant to say, I don't want something that's harder. And so the communication break was the fact that harder wasn't helping anyway. So, because if we can crack really hard, quote unquote, hard passwords that are 15 characters long in 20 seconds or less, making it harder is not really helping. Making it more convoluted wasn't really helping. And so what we found, the ones that were working the best were phrases intermixed with the numbers or symbols. What I mean by that is whenever someone had a password where all the letters were together and they were numbers or symbols before or after it, those are actually cracked really fast because the words were all together, and it's just a question of twiddling some symbols on either side of it to be able to crack the password. So some people would have really long passwords like steak dinner 12. Well, okay, that's just a word right there with a couple of numbers, not hard to hack at all. So the ones that lasted really well were actually a lot of short words.
Like sentences strung together?
Yeah, a sentence, a phrase, a limerick, what have you. But it was sentences where the numbers were in between the words. Okay. So you would have to have a word and then be able to rotate characters with the number and then another word and then another number. And that became very hard. Now, mathematically speaking, any password can be cracked given enough time. And computers are getting faster, obviously. But everyone is supposed to change their password. So if you're changing your password, the amount of time people have to make use of a decent strength password is pretty finite. You don't have forever to sit there and crack something and play with it before it becomes unfeasible and you can't really do anything with it. So a string of words with numbers in between become very useful, especially if it's more than one number. Mailman 1 is not a very good password, right? Yeah. You just try to rotate some numbers, you're going to try 0, then you're going to try 1, and now you have the password. It's not very hard. But intermixing those short words with a couple of numbers, another short word, couple of numbers, short word, a couple of number, not very hard to remember because you can have it be part of a sentence. But strength-wise was much better than sitting there trying to replace 4 of the 10 digits in your password with @ signs and exclamation points and dollar signs. It just wasn't really effective in comparison.
Do the way these work, do they have to, you might not know this, but does it have to guess the whole thing successfully, or can it, the way the computer works, does it have to say, let's say Bob was the first part of does it have to get the B the O and the B, and then the computer says positive, 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 like 111? Or does it have to go the whole thing perfect?
So if people keep things up to date, it does not do that. So for example, in old operating systems, NT4, Windows 2000, you could crack passwords in chunks. And that's one of the main reasons that people who still have old Windows 2000, Windows 2003 servers and are basically dumbing down the security of the entire environment because everything has to come down to the lowest common denominator, that's actually still possible in some environments. And it also depends on what system you're using. But if people are updating, patching, staying with relatively current. In some cases, that's possible, but it's not as easy as it used to be. And it is not a clear mathematical chunk of first you crack the first 8 digits, then you crack the next 4 digits, then you crack the next 5. It's not really chopped up that way because as security's gotten better, how that's chunked out has been scrambled. So that makes it a little bit easier. Now, not all systems work that way, so it does somewhat depend on the system you have. But we actually found that issue in this incident review as well, and it's because of legacy systems that are being forced to stay in the environment, and quite literally, it makes everything operate as if it's still that old.
Because the authentication has to work off of that member of the domain?
Not because it bounces off of it, but because you have, think of it, if you have a pile of people who are biking together, that whole group, if they're going to stay together, will go as fast as the slowest peddler. Same thing is true. So that worst security server in your environment, everything has to be able to communicate all the way down to that level. And so it can't take advantage of the newer security changes.
Okay.
So for example, there's something called a hash, very popular for passing the hash attacks. That's how some credentials are stored. If you have older systems, you will have different types of hashes, some of which are very, very easy to crack.
Okay.
And it doesn't matter if your domain controller in Windows is updated. If you've got a bunch of member systems that are very, very old, everything has to come down and communicate to that level for everything to be able to operate correctly.
Oh, that makes sense. Interesting. Now, is there any way, if a company can't force password changes en masse to get to a standard that works, can they lay in, and can they look at two-factor as a means to mitigate something that might be not as strong? Would a weak plus a strong second factor negate it, or do you need layers of both sides, really strong on both sides?
It does and it doesn't. So a weak plus two-factor gets rid of most of the external attacks that people fall victim to. As a good example, a number of the hacks were someone logging into Outlook Web Access and then stealing an executive's email and then using confidential merger files, using wire transfer information, using W-2 information, and just ripping it out of email. Not really an interesting hack. They just logged in and forwarded the message to a fake Google address. Not really hard at all. So two-factor helps with pieces like that, absolutely. And that's happening more and more with phishing attacks. People fall victim to a phishing attack. They give out their password in the phishing attack usually. And two-factor authentication prevents someone from them using that password against them. Yeah. However, once things are inside the walls, malwares, ransomware is key there. Password strength is still actually really important, because if I've got a mini cracker and you download my malware or Trojan or ransomware, I can sit there and try to crack some hashes, and if the passwords are all weak, I'm going to get them probably faster than your behavioral analytics will notice you have a weird process running. And now all of a sudden I'm an administrator, I get to escalate my privileges and run around your network because of that point of view that says, hey, two-factor authentication means my password can be weaker. But I think that's another piece that really needs to be explained is IT is traditionally really bad at telling people to make their password complicated. And they really need to be telling people to make the password interesting. An interesting password you can remember. It's going to be longer. Yeah. And it sounds less scary to tell someone, make your password interesting versus make it more complicated. Right. Complicated's a negative word.
That could almost be like the title of this blog post, make your password interesting, don't make it hard.
Make password interesting. I had one password that remained uncracked in this one case, and it was a password created out of annoyance that was basically, I'm not going to do it. It's not really hard to remember the statement, I'm not going to do it, but
no symbols or anything.
It was really, really long.
Yeah.
It had really weird combinations of words. You would have to run a very complicated algorithm on top of dictionaries to get all of those words.
Yeah.
And sadly, that was really effective. Now, of course, you have to change it, but it's not really hard to come up with a sarcastic sentence once every 90 days to change your password and have it be pretty decent. Realistically, we still think there should be numbers and symbols in there, but just as an example, sometimes a raw combination of words, people don't do that. Intrinsically, people are lazy. That's why you have passwords we find like welcome one, because that was what they were given when they started. And ever since then, they changed it. So, for example, welcome 9. That guy's worked there for 9 years. Every year he changes his password once. And it's funny, but that's really what you find. And we found a lot of patterns. And so it was kind of interesting as we went through having hacked the passwords, we could then sit there and say, well, what do the passwords tell us about the environment? And you would be really, really surprised where, as an example, we found 51 accounts that had almost the same password because people who are similar think similar. And if they've had similar training and had similar experiences, the chance of them using basically the same password is really high. So we found about 50 with literally the same password.
Oh my gosh.
And so either IT has a bad habit of setting all new users to one password and then they really don't vary much from there, or you have groupthink. Groupthink is a standard business issue. You put 5 developers in a room and you ask them a question, you'll get a developer answer. That's groupthink. So we found tons of issues like that. So for an example, we found 51 that were all one word with 1, 2, 3, 4 after that one word, and that was 51 different people's passwords. We found another common word that had about 27. We found that another 60 that were either summer or winter with a 4-digit year afterwards. And depending on the physical location, the number of, it was very interesting. There were for Maryland, a lot more Ravens fans than Redskins fans, but that's in there. And in reality, it's just a word, Ravens is just a word. Redskins is just a word. Yeah. And so you can kind of look at the data and then start seeing how people think. But realistically, when we find the same issue with in-house developers, outsourced developers, IT folks themselves, you start to realize, okay, what people think is good is incorrect. And we definitely found that because if you got a 12-digit password and 6 or 7 digits are symbols or numbers, that's supposed to be really, really hard. And when it's instant, that's not really, really hard anymore. And unfortunately, computers at this point are learning way faster than people are. So, keyboard patterns and natural character replacement and things like that, it's just too easy. And some of the malwares now, it's really interesting. They will run the cracker on the processor in your graphics card. So it won't even slow down your PC because most people don't even use the CPU in their graphics card because they're not doing 3D video editing while playing with Microsoft Word.
The GPU is faster anyway.
Yeah, the GPU is faster anyway. And so it'll just eat that. And so there's nothing that's going to go tell a network operations, hey, the CPU on that PC is spiking because they're not even using the CPU. And like I said, it's faster.
Oh, that's pretty clever.
Yeah, and so that really becomes an issue because once you start cracking passwords, then you can pretty much do whatever you want.
Now, we've had recently someone, this happened to a couple of different accounts, the wire transfer, I guess you can call it wire transfer fraud.
Mm-hmm. Yeah, we've seen wire transfer fraud, we've seen the W-2 scam, and we've seen basically a kind of lame request for PayPal payment. We've seen all 3 of those quite often.
But they're fundamentally based on the hacker has to get access to that password and then lie almost as it has to lie as a legitimate user.
Exactly. So originally, these were considered kind of spear phishing attacks. And the better spam filters got at blocking them and the more users were trained not to fall for phishing attacks, the less those were able to work. So like usually the W-2 scam would start as just kind of a blind external phishing attack. Really, it was trying to catch people with the idea of here's a fake looking email that came from the CEO. The CEO is yelling. You've been trained to respond when the CEO yells. Therefore, you do immediately what they say. You don't really think about, does this email look weird? Is the address mistyped? Little things like that. Next thing you know, somebody sends all the W-2s from payroll out to China. And then you have the issue of a data breach. And really has to do tax fraud, which is really a good money maker, very popular, simple IRS tax fraud at that point. But now what they found is if they want to make it even basically, if they want to get even the best trained people to fall victim to it, the best way to do it is actually send the email from the person. And so once someone loses their password, you just log in as the user. And what they're doing is they're looking at the sent mail. They're finding the conversation in flow. And instead of sending a random email, they're just replying to an existing conversation. Because what's safer than continuing a conversation you've already started? They're replying to that existing conversation, and then they inject oh, sorry, we changed our bank number. You didn't know that. Quick, here's the new banking number. But it's in the flow of a conversation about an overdue invoice or a payment you have or a deposit you owe. And so they're staying in, it's a good word for it. They're really staying in character.
They're staying contextually within the message. So it doesn't seem as it's like a request from left field.
Exactly. And so in this case, for example, what they can do is, because they're in, and they're doing all of this with Outlook Web Access, so it's not like they hijacked a PC, they're just using a web browser. So they're going in through Outlook Web Access or OWA or Outlook.com, whatever you want to call it. They log in as the user, and when they go to reply, they just change some of the return addresses. And then what happens there is when they send the response of, oh, are you sure you want me to change this routing number? That's going to now a fake account who's going to reply yes. And when you think of spam filters are usually set up that if you sent that person an email, they must be legitimate. Otherwise, why on earth would you email them? And so in this situation, they get the victim to send the first email, which helps them bypass spam filters, and then lifts away the issue from the person whose password they stole. Because now they're communicating directly with the victim, and the person whose password was lost or stolen, they're really the patsy for the criminal. They are not the person who's continuing to be used, because they don't want to lose the ability to send emails as that person.
So they're sending outbound. They're picking up on via Outlook Web Access, which for the non-technical folks, which is probably not a ton, but for the non-technical folks, they don't have to be inside the network for that.
Correct.
Which is a huge bonus for a hacker. And then that sent mail is going, or that person is reply all, and so it goes out to the potential victim to ask them to pay their bill with a new routing number and potentially a new .co or whatever domain name, which is just subtly different. And then there's no need to more back and forth communication, right? Because they're now directly on a landing page.
Correct.
To pay the bill.
And typically what they're doing there is, in terms of the person's account they're spying on, they're specifically not touching anything. They're just looking at it so it doesn't trip any flags. So they're very, very, very carefully saying, I don't want to put the credentials I've stolen at risk. So I'm just going to look. And then when I take action, I'm going to do it out of band. So for example, in this one case, even though they stole person A's credentials, when they communicated as person B in the chain. And that way, anybody going to look into it would go look at person B, see that everything's fine with person B, and say, okay, you must be getting phished from the outside world. And they never really refer back to person A, even though that's where the conversation started and how they made everybody feel safe. Because if they're criminals, right? So standard criminal activity, if you've got a mark that you can use, you don't want to destroy or spoil that mark. You want to protect them so you can keep using them over and over again. And that's the nature of these kind of more advanced phishing attacks, is that ability that says, oh, if you're silly enough to lose your password, you don't have two-factor authentication, your password was guessable, you fell victim to a phishing attack and gave someone your password. If those things are true, then they don't want to spoil the fact that they can keep using you over and over and over again, kind of like blackmail. So
the net of this particular example is, from a password point of view, if we had infinitely take the percentages way down by following the interesting, not hard model of password creation, and then because of the external access for OWA, having obvious second factor in would actually make it very difficult as well by having the second factor, right?
Absolutely. Two-factor authentication solves like 90% of the world's problems for remote access.
Are there any limits per se with Office 365 at this point? Is there any limits from this type of attack being, whether it's on-prem, off-prem, or a straddled hybrid
Not really.
environment?
You can protect it in any direction, and no direction is safer than any other. unless you purposefully make it be protected. None of them get protected by default.
So OWA is client independent, so you don't have to be on Windows 10 to have second two-factor with Office 365 or any other special, browsing capabilities. It's just
correct. Yeah, nothing special.
It's actually the dumber that browser, it's Microsoft's best interest to have it as dumber as possible, right? So they don't need to have a client side there. Okay, that's interesting. Well, I think that's good. That's good for today. I think that's having done a pure tech-oriented, super practical passwords, two-factor, good case study, good, practical example of how we've observed this happening. And I think this is going to be very useful for everybody listening. So until next time, everybody have a great day. So there you have it. This wraps another episode of Bill Murphy's RedZone podcast. To get all the relevant show notes, please go to our blog at www.redzonetech.net/podcast. Additionally, make sure you go to iTunes and leave your comments in iTunes about the show. This helps our show rankings enormously and it helps support the show. Until next time, I appreciate you very much for listening. Thank you.